Hi, good morning everyone. Hope you are doing well. So let's discuss about this question in the screen. Determine the initial direction of the deflection of charged particles as they enter the magnetic field as shown in the figure below. Alright, so we have a positive and we also have a negative. Okay, I'm circling it with my mouse. So we have a positive and we have a negative. Now, for a charged particle in a magnetic field, you know that we have to use the right-hand rule, right? The right-hand rule whereby the thumb points towards the force, the index finger points towards the velocity or the direction of the charge, and your middle finger points towards the direction of your magnetic field. However, the right-hand rule direction applies for a positive charge. If your question asks about negative charge, then the answer will be whatever the opposite direction dictated by the right-hand rule. Okay, so let's try the first one, the first question A. So we have a positive charge. Remember, positive charge, right-hand rule. So your magnetic field is going into the page. So let's say my page is here. It goes into the page. Okay, it goes into the page like that. And my charged particle is going to the right, which means that my force goes upward because this is where my thumb is pointing. It's going upwards. Into the page, velocity to the right. This is my index finger to the right. Okay, into the page, to the right, your force is upwards. Okay, so the answer is up. Correct? Now, figure B. Your B is going upwards now. It's not into the page, but it's going upwards. And your velocity is going to the left, right? To the left. So okay, that's a little bit difficult for me. Upwards to the left, like that. So your force is pointing into the page. It's pointing into the page. It's going away from me, which means that it's going into the page. Okay, so B goes up, velocity goes to the left, your thumb goes into the page. Now, this is a negative charge. If it's going into the page, which means, if my right-hand rule says it's going into the page, which means that it will be the opposite, which is out of the page. And this is the answer. Okay. So figure C. It says the answer is no deflection. Let's see. So we have a positive charge particle here, and we have our B is parallel to your positive charge. Remember, the right-hand rule says for magnetic force to happen, your V and B should be 90 degrees. Look, this is 90 degrees. If your charged particle and B is in parallel, they are in the same plane, there is no magnetic force. So that is something to remember. Your V and B, if it's like this, it should always be 90 degrees. If it's in the same plane, no force is produced. Okay, so the next one is D. So it says here you have a charged particle going upwards. Okay, so your index finger goes upward, and then your B is 45 degrees. It's like that, but slightly like this, like that. Instead of a perfect 90, it's like a little bit smaller. And your thumb goes into the page. Okay, again. So your index finger is your velocity, and then your index finger is your B. So instead of 90 degrees, it's slightly smaller. Okay, which means that the magnitude of the force will be smaller. And then your thumb points into the page, and that is what the answer is. Okay, I hope this helps. Please try it yourself. Let me know if you have other questions. Bye-bye.